Second step, extraction of metal from the concentrated ore. The method used for the extraction of metal from the concentrated ore depends upon the nature of metal. Based on the reactivity, the metal have been grouped into three categories: metal of low reactivity, metal of medium reactivity, and metals of high reactivity. The method employed for extraction of metal from the concentrated ore will depend upon the position of the metal in the reactivity series. Now, we are going to discuss about extraction of metals which are highly reactive, yani extraction of metals which are high up in activity series. How they have to get, how can we obtain the metal from their ores? Those metals which are highly reactive like potassium, calcium, sodium, magnesium, aluminum, etc., which are lying on the top of the activity series, cannot be obtained by reduction of their oxides just by heating with the carbon or aluminum. Why? Because these metals have high reactivity, have highly reactive metal have greater affinity for oxygen rather than carbon or aluminum. Thus, their oxides are very stable, are highly stable. Thus, the oxides of highly reactive metals are very stable. Hence, just by heating with the carbon cannot reduce them to the free metal. So, for reduction of high metals which are highly reactive, what we need to do with them is that first of all, they needed to be changed into molten or fused form. Then they needed to be electrolyzed so that through electrolytic reduction we can obtain the free metals. Once the electricity is passed through, what happens at that time is that the metals being positive will be liberated at cathode, and the non-metals which are negative will be liberated at anode. For example, if we talk about the molten sodium chloride, first of all, the sodium chloride, this salt, has to be heated so that it can be converted. It can be converted into molten form. Then, once it gets converted into molten form, electricity is passed through this metal. Once the electricity is passed through the sodium chloride, it will get decomposed into sodium ion and chlorine ion. Sodium ion will go to the cathode, whereas chlorine ion will be liberated at anode. Sodium ion will gain the electrons at cathode and thus reduce to sodium atom, whereas chlorine ion will lose the electron at the anode and thus get oxidized to chlorine atom. This is how can we separate the metals which are high up in activity series.